Let's look at another thing that's related to weak acids and weak bases. That's the concept of a buffer. So a buffer is a mixture of a weak acid and its conjugate weak base. A buffer is something that helps to maintain a consistent pH. So that pH can vary from a very low pH to a very high pH, depending on the type of buffer that you're working with. And buffers are exceedingly important to the human body. They're what allow the body to keep the pH in your blood to a very narrow range. If you go outside of that very narrow range, then people die. So you have to maintain buffers and maintain that pH very carefully. So it's very important to understand how buffers work. So essentially you have a weak acid. So I'm just going to put a generic weak acid. Combines with water. And it's in equilibrium with its conjugate base and hydronium ion. So this is the weak acid. This A- is our conjugate base. So there's a mixture of both of these. So you have some weak acid and you have some weak base in your solution. So what this does is, if I add base to this, so if I add something basic to this weak acid conjugate base combo, this is going to perturb our equilibrium. So this goes back to Le Chatelier's principle and equilibrium. If I add a base, then what's going to happen is we're going to have our HA. It's going to combine with this base, and it'll form the conjugate base and conjugate acid. So this HA is going to absorb the base in a way, and you notice there's and you're going to get a solution that's about the same pH. So the pH changes very little. If instead I add an acid, so that A-, I add an acid, it's going to convert back to the HA. So it's going to plus a conjugate base. So, and this also will maintain the pH, because notice we're not producing more H3O plus here. It's essentially absorbing that acid or absorbing that base, going back and forth. How much acid or how much base depends on the buffer and the pH that we're talking about. So we want to make sure that we can create buffers or calculate with buffers at specific pHs. So we're going to start and calculate the pH of a buffer. And you may find there's other formulas and solutions to how to do these types of problems. I'm going to go with the core way of doing it. I'm going to go back to our acetic acid in water. So I want to know what is the pH of a buffer solution with 1.2 molar CH3COOH and 0.65 molar CH3COO-. So I have 1.2 molar and 0.65 molar. I don't know what H3O plus is. And remember, this is a liquid, so it's not going to be involved in our equilibrium. We'll write our equilibrium expression. We know the Ka for this, because it's been given to you, 1.8 times 10 to the negative fifth. Now I'm going to rearrange this equation to solve for H3O plus, because H3O plus is what I need, because I want my H3O plus, because remember, pH is equal to negative log of concentration of H3O plus. So first I need to know what my H3O plus concentration is before I can use this pH equation. So I'm going to rearrange. So I'm going to multiply my Ka here by concentration CH3 COOH over concentration CH3CO minus. Because I need to cancel out on this side. So CH3COH, I need that on the top of my fraction. CO minus, I need it on the bottom. So that this is going to cancel out here, this is going to cancel out here. And remember, whatever we do on this side of the equation, we must do on this side as well. So this is where I come up with this equation that our concentration of H3O plus is equal to 1.8 times 10 to the negative fifth times the concentration of our acetic acid over our acetate ion. We know the acetic acid and we know the acetate ion from the problem, so I can plug those into my equation. So I'm going to plug in my 1.2 molar acetic acid and my 0.65 molar acetate, calculate through, so I get my concentration of H3O plus is equal to 3.3 times 10 to the negative fifth. Remember, we still need one more step because we need to take our pH, take the negative log of that H3O plus concentration, and that will allow us to calculate the pH, which comes out to 4.5. One thing to be careful when you're doing your pHs, and something to double check on yourself, is this pH should be somewhere around 5. So it shouldn't be like 10 or 15 or something. If we're talking about pH, we're talking about the negative log, and it's log 10, so we're talking about the exponent on 10. And it's the negative exponent of it. So we should have a number somewhere near 5 for this final value. So this 4.5, it makes sense. So do make sure you practice with buffers. Try a few different concentrations of buffers and see what the pH looks like. You'll notice that there's not a huge change if you're talking about the same acid-base combo. That's kind of the point.